Hello, ladies and gentlemen. I am Dr. Claudia Albers, Planet X researcher and professional physicist. And today I'd like to bring to you another one of my articles. This one is entitled Gravitational Shielding by Superconductors and Stealth Technology. Now, in 1996, Dr. Evgeny Podkletonov, a Russian material scientist, discovered that all objects placed above a superconducting disk, and thus within a cylindrical region with the same radius as the disk, lost mass. It did not matter how far above the disk the objects were placed, they all lost mass. This would mean that the superconducting disk created a cylindrical region above the disk where gravity shielding occurred. In other words, the Earth's gravitational field was not felt with the expected strength by objects above the superconductor, showing that the Earth's gravitational field was reduced in the cylindrical region above the superconductor. And this is illustrated here. This is the superconducting disk, and this would be the cylindrical region above it, where objects would seem to have a lesser mass due to the Earth's gravitational attraction in this region being reduced. Now, a slight mass loss of objects above the conducting disk would have to mean that the gravitational attraction exerted by the Earth on the objects would be less than normal. But since Earth's gravitational attraction on an object decreases with altitude, this would also suggest that the objects would seem to be at a higher altitude than they actually were. And since gravitational energy is associated to altitude, this would also mean that the gravitational energy of the electrons in the superconductor would have to have decreased so that they had less energy than electrons usually do at that altitude. And you may look at Article 279 entitled Lightning and Gravity in the Earth's Atmosphere for more details about the energy levels associated with gravity in the Earth's atmosphere. But here we have what is illustrated, what we would expect to have occurred in order for objects above this region where the superconductor is. So this would be the superconductor. And then we would have to have the energy levels that would move downward. So they would occur at a lower altitude than normal in order for objects in this region to experience a lower gravitational attraction towards the center of the Earth than objects that are not above the superconductor. So if an object, say at the exact same altitude, so this object at this altitude is supposed to experience this gravitational attraction represented by the green arrow. Then an object above the superconductor would experience a lower gravitational attraction, which would be the same as an object on this side just being at a higher altitude. So here above this energy level indicated here with energy E2. So this would mean that the energy level above the superconductor, instead of being here at this altitude, appears at a lower altitude. So this object experiences a lower gravitational attraction as if it was at a higher altitude than objects outside that region. Now, the main characteristic of a superconductor is that the electric currents, which is the movement of electrons, flow across the conductor without resistance. So once set up, a current will go on flowing forever. This suggests that electrons in a superconductor are accelerated by an extra electric potential inside the material, so that the electrons are not slowed by the usual normal process inside conductors, and that this acceleration results in the electrons losing gravitational energy. This therefore suggests that accelerated electrons lose gravitational energy. This can also be explained in terms of electrons in the Earth's atmosphere experiencing an acceleration along the horizontal direction, i.e., without changing altitude, which is illustrated here. So moving horizontally. And this would then, without changing, would then be expected to absorb photons in order to equalize the internal gravitational energy with that of the energy level they are in, which is associated to altitude. But basically, this shows that whatever happens in atoms is what also happens with large celestial objects like the Earth. So here we have an electron which is moving along a horizontal direction, but it moves faster. This is represented by the arrow. The red arrow is longer here, meaning that it's moving at a faster speed. So it had to have accelerated. But it didn't move up and down. So it meant it lost gravitational energy without moving in altitude, which is usually the way that it would change gravitational energy. So that means that it would tend to equalize its gravitational energy to the level that it is moving in. So it would absorb photons. Now, the loss of gravitational energy by electrons as a result of acceleration, the resulting absorption of photons, has implications which may be helpful in understanding how stealth technology works. Stealth technology makes aircraft invisible to radar. Radar works as a result of radio waves being reflected off objects. The time delay between the send and return signal determines the distance to the object that caused the radio waves to be reflected back toward the source. So this is illustrated here. We have a transmitter, this is the radar transmitter, emitting radio waves, which are then reflected by an object, which is this aircraft here. So the radio waves return to the transmitter, but there's a delay between when the pulse was emitted and when it is received again. And from this delay, it can be calculated the distance at which this aircraft was that reflected the radio waves. So if an object absorbs the radio waves impacting it instead of reflecting them, the object will be invisible to radar. Thus, by causing electrons around an aircraft to accelerate to the right speed so that they lose enough gravitational energy, which will then result in these electrons absorbing radio waves or radio wave photons of the exact wavelength emitted by the radar, which will then make it invisible to that radar. The way to cause electrons in the air around an aircraft to accelerate is to apply an electric potential across the aircraft's outer shell. This will set up an electric field around the aircraft, which will cause electrons in the surrounding air to accelerate and absorb photons. So this is illustrated here. So you set up an electric potential along the outer shell of the aircraft. This sets up an electric field. It causes electrons to accelerate. It also causes electrons in the air just above it to accelerate because they also experience this electric field. And this will then cause these electrons to absorb photons. And that would mean that the photons emitted by the radar would be absorbed and it would be as just they carried on forever and never returned. So there's no delay detected, so the radar would presume, or the radar operator, that there are no objects to reflect the radio waves back. Now, the difference between electrons in superconductors and electrons in the Earth's atmosphere is that electrons in superconductors do not absorb photons, but instead cause the gravitational energy levels in the Earth's atmosphere to change. This implies that the shielding from the Earth's gravitational field for superconductors actually occurs at the surface, which somehow does not allow electrons inside to equalize their energy level, their energy with the outside energy levels. So, in conclusion, gravitational shielding associated to superconductors suggests that accelerated electrons lose gravitational energy and should thus absorb photons in order to equalize with the surrounding environment's gravitational energy. Thus, this in turn is helpful in the understanding of how stealth technology may work. And here are the references. This is Dr. Claudia Albers, Planet X physicist. Thank you for watching.